So today what we're going to do is we are going to go over the answers to Lesson 12. Lesson 12 is kind of the starting learning point of these angle relationships. Number 1, red, identify all the pairs of corresponding angles. When you came down to the picture, where's your first set of corresponding angles? Give me one.
1 and 5.
Angle 1 and angle 5 are corresponding. They're on the same side of the transversal, both on top of the respective lines. Go ahead.
3 and 7.
3 and 7. Same side of the transversal, on the bottom of the respective lines. Yes.
2 and 6.
2 and 6 on top, both to this side of the transversal, and the last pair is
4 and 8.
4 and 8, both on the bottom on this side of the transversal. The second part of question 1 asks, read carefully, are the pair of corresponding angles equal in measure? How do you know? Yes.
No, because line 1 and line 2 are not parallel.
Very good. Because in the picture there is no indication or notation showing that these two lines are parallel. And because in the question it doesn't state that the two lines are parallel, no, they're not going to be equal in measure, because in order for them to be equal in measure, the lines have to be parallel. Questions on that? All right. Number 2, give me my alternate interior angles. Alternate interior angles. Give me one pair, Cody.
3 and 6.
Angle 3 and angle 6, opposite sides of the transversal on the separate lines. And the last pair of alternate interior, Bonnie?
Angle 4 and 5.
Angle 4 and 5 are your other alternate interiors. Are these equal in measure? How do you know? And they're not because there is no indication that the two lines are parallel. Very good. Number 3, now, use an informal argument to describe why 1 and 8 are equal in measure if angle 1 is parallel to angle 2. So now that we know they're parallel, it tells us to assume they're parallel. Are these two equal in measure?
Yes.
Why? What relationship do they have? Yes.
Alternate exterior.
These two angles, angle 1 and angle 8, are alternate exterior angles. Now, in order for angles to be congruent is our key word there, what do you have to have in order to be congruent? We learned it as we began this section of the book. What has to take place for angles, shapes, lines to be congruent to one another? Yes?
Parallel lines and transversal.
There has to be parallel lines, but that isn't the definition of congruency. What has to happen for congruency to happen? There has to be a sequence of rigid motions. What rigid motion will put 8 directly on top of 1? We'll put an alternate exterior angles directly on top of one another.
Translation.
A translation. So if I slide this line up the transversal, just sliding it, will that put this angle on top of this angle over here? No, it's not a translation. Bonnie? Reflection. So if I pick a line and I were to flip this upside down, does that put 8 directly on top of 1? Nope. What do I? Rotation. Watch this, ladies and gentlemen. If I take my entire set of parallel lines and my rotation point is here in the middle of the picture, and I'm going to rotate it, tell me when you get 8 directly onto where 1 was located.
Stop.
What degree measure was that?
90.
I flipped it all the way upside down.
180.
It's a 180 degree rotation. With a 180 degree rotation, look at this. 1 is where 8 was located. 8 is where 1 was located. What else do you notice besides your alternate exterior angles being in place of one another? What other relationship has replaced one another? Yeah?
2 and 7.
2 and 7. These two are also alternate exterior angles. What other ones? Yes. 4 and 5. So besides my alternate exterior angles following a sequence of rigid motions of rotation, my alternate interior angles by rotation of 180 degrees will lay exactly where their angled relationship is. Okay? Now, with our corresponding angles, so we just proved that by rotation, we can put our alternate exterior angles on top of one another and our alternate interior angles. What rigid motion does corresponding angles require? For example, 1 and 5. What rigid motion would take 5 to get directly on top of 1?
Translation.
It is a translation. It is a slide. Okay? Your corresponding angles take a slide or a translation. Your alternate angles take a rotation. Okay? And we can prove they're congruent by our rigid motion sequence, tying in what we learned in the past to our angle relationships. Are there any questions? All right, the rest of these we can fly through then. Number 3, why use an informal argument to describe why 1 and 8 are equal in measure? Because of a sequence of rigid motions of rotation, they end up on top of one another. They are corresponding angles to each other. Number 4, assuming line 1 is parallel to line 2, if the measure of angle 4 is 73, what is 8? Go ahead. 73 because of 7 and 3 are corresponding? Yep, 7 and 3 are corresponding. But I wasn't asking about 7 and 3, I was asking about 4 and 8. 4 and 8 are what to one another? Corresponding too, right?
Yep.
Yep, okay. And then assuming angle 3 is 107, what is 6? 107 because they are alternate interior angles. Thank you. I was reading 73 as 7 and 3. It's my first time reading words. Number 6 we're on. Assuming line 1 is parallel to line 2. If angle 2 is 107, what is 7? Because they are alternate exterior. Very good. Would your answers to 4 through 6 be the same if you were not told that they were parallel? No, you would not be able to assume they have the same degree of measure unless you know those two lines are parallel. Would your answer use informal arguments on why 1 and 5 are equal in measure? 1 and 5 have what relationship? They're corresponding, so what rigid motion makes them equal? Translation. Perfect. Use an informal argument why 4 and 5 are equal? 4 and 5 are alternate interior angles to one another, and what rigid motion makes them congruent? Rotation. Perfect. Finally, number 10, assume line 1 is not parallel to line 2. Why can angle 3 not equal angle 7? Because the two lines are doing what? Traveling at different rates. Okay? And if you have two lines traveling at different weight, one line crossing them will not create the same angle. As we finish up lesson 12, this is what you know, or you should know at this point. You know that corresponding angles, alternate interior angles, and alternate exterior angles of parallel lines are equal. Everybody knows that? Okay? Therefore, this is the theorem. Parallel lines, you get these equal angle measures. The converse theorem to that, students know that when the pairs of angles are equal, then the lines are parallel. Okay? If you have parallel lines, you get equal angles. The converse theorem to that is if you have equal angles, then you have parallel lines. Okay. 2, students know that corresponding angles of parallel lines are equal because of the property of translation. Very good. And students know that alternate interior and alternate exterior angles are equal because of rigid rotation, the rigid motion of rotation. Very good. And then you can draw arguments to conclude that. Any questions on what you know at the end of lesson 12? And everybody knows those things? Thumbs up? No? Okay, stop.